In this episode, we look at monitoring protocols and data flow, which means the ways security information moves from devices, systems, and networks into the tools that help people understand what is happening. Monitoring does not work just because an organization owns a security dashboard. The dashboard needs data, and that data has to come from somewhere. Firewalls, routers, switches, servers, cloud services, endpoint tools, and applications all produce signals. But those signals must be collected, transported, organized, and displayed before they become useful. Some data describes traffic patterns. Some data describes device health. Some data records security events. Some data is created when a team mirrors network traffic for closer inspection. Once you understand how monitoring data flows, the tools from the previous episode start to make more sense because you can see what they depend on. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. NetFlow is a technology used to summarize network traffic conversations. Instead of capturing the full contents of every packet, NetFlow records metadata about traffic flows. A flow is a conversation pattern between systems, such as one device communicating with another device over a particular protocol during a period of time. NetFlow can show source and destination addresses, ports, protocol information, byte counts, packet counts, and timing details. This helps a security team understand who is talking to whom, how much traffic is moving, and whether the pattern looks normal. NetFlow is useful because it gives visibility without requiring the organization to store every packet. It is especially helpful when teams need to spot unusual traffic volumes, unexpected destinations, possible data movement, or communication with systems that do not normally interact. NetFlow does not usually tell you the full content of the communication, and that is an important limitation. It may show that a workstation sent a large amount of data to an external address, but it may not show exactly what the data contained. That is still useful because many investigations begin with patterns rather than complete answers. If a server that normally handles internal database traffic suddenly communicates with an unfamiliar overseas address, the flow data can raise a question worth investigating. If many devices begin connecting to the same external destination at regular intervals, that may suggest malware calling back to an outside system. NetFlow gives a security team a map of traffic behavior. It does not replace logs, packet captures, or endpoint evidence, but it can guide the team toward the right places to look. Simple Network Management Protocol, SNMP, is used to monitor and manage network devices and other infrastructure components. It can report information such as device status, interface usage, errors, uptime, and performance conditions. A network team may use SNMP to know whether a switch port is overloaded, whether a router interface is down, or whether a device is approaching capacity. Security teams care about this because availability and security are connected. A failing network device can disrupt business operations, and unusual device behavior can sometimes point to misconfiguration, misuse, or attack activity. SNMP can also generate alerts when certain conditions change. For example, a device may report that a link went down, traffic rose sharply, or an interface began showing errors. SNMP needs to be handled carefully because management data can be sensitive. If the protocol is configured poorly, it may expose information about devices, interfaces, network structure, and operational status. In some cases, weak configuration can even allow unauthorized changes, depending on the version and settings in use. From a Security Plus point of view, you do not need to become a deep SNMP engineer, but you should understand why it appears in monitoring discussions. It gives network management systems visibility into infrastructure health and behavior. That visibility can help teams maintain uptime, notice changes, and investigate suspicious patterns. At the same time, management protocols should be protected with proper access control, strong authentication where supported, careful configuration, and limited exposure to trusted management systems. Syslog is a common way for devices and systems to send event messages to a central logging destination. Many firewalls, Routers, switches, servers, appliances, and applications can generate syslog messages. These messages may describe logins, configuration changes, connection activity, system errors, blocked traffic, service restarts, and other events. The value of Syslog is that it gives many different technologies a shared way to forward event information. Instead of forcing a security team to check every device separately, Syslog allows those devices to send their records to a collector, log server, or security monitoring platform. Once the messages are centralized, they can be searched, stored, correlated, and included in reports. Syslog is one of the basic building blocks behind many monitoring programs. Syslog messages are useful, but they can vary widely in quality and detail. One device may send rich messages that include usernames, source addresses, destination addresses, actions, and reasons. Another device may send brief messages that require more interpretation. The same kind of event may be described differently by different vendors or products. This is why normalization matters. Normalization means converting different log formats into a more consistent structure so tools and analysts can compare events more easily. Time settings also matter because an investigation often depends on knowing the order of events. If one device reports time incorrectly, the story may become confusing. A healthy syslog process needs good configuration, reliable transport, protected storage, and enough context to make the messages useful during detection and investigation. Security Content Automation Protocol, SCAP, is used to support standardized security configuration and vulnerability information. It helps tools describe security checks, configuration expectations, and known vulnerability data in consistent ways. This matters because organizations often need repeatable methods for checking whether systems match a required baseline. A baseline might define secure settings for an operating system, application, or device. Without standard content, each tool might describe findings differently, which makes reporting and comparison harder. SCAP helps bring consistency to automated assessment. At the Security Plus level, the main idea is that SCAP supports security automation by giving tools a common language for checking systems against known standards, policies, and vulnerability references. SCAP fits into monitoring because configuration and vulnerability data are part of operational security visibility. Security monitoring is not only about detecting active attacks. It also includes understanding whether systems are drifting away from expected secure states. A server with insecure settings may not be compromised today, but it may be easier to attack tomorrow. A workstation missing an important security configuration may create risk even before an alert fires. Automated checks based on standardized content help organizations identify those conditions more consistently. This supports reporting, remediation planning, and compliance activities. You can think of SCAP as part of the bridge between security policy and technical measurement. It helps answer whether systems are configured the way the organization expects them to be configured. Port mirroring is a technique used to copy network traffic from one port or segment to another destination for monitoring or analysis. A switch can be configured so traffic from a selected source is copied to a monitoring port where a sensor, intrusion detection system, or packet analyzer can inspect it. The original traffic continues to its destination, while the mirrored copy gives the monitoring tool visibility. This is useful when a team needs deeper network evidence than summary data can provide. NetFlow may show that communication happened, but mirrored traffic may help show more detail about the communication pattern. Port mirroring is often used for troubleshooting, security monitoring, malware analysis, and investigation of unusual network behavior. Port mirroring also has practical limits. Mirroring too much traffic can overwhelm the monitoring tool, fill storage, or create performance concerns. The mirrored traffic may include sensitive information, so access to captures and sensors must be controlled. Encryption also affects what can be seen. If traffic is encrypted, the monitoring tool may still see addresses, timing, and volume, but not the readable contents of the communication. Placement matters as well. A sensor only sees the traffic that reaches the mirrored point. If traffic moves through another path, the tool may miss it. This is why monitoring architecture requires planning. The organization needs to decide which traffic is most important to observe, where sensors should be placed, and how captured data should be protected. Dashboards bring monitoring data into a visual form that people can understand more quickly. A dashboard may show alert counts, traffic trends, device health, authentication activity, vulnerability status, data movement, cloud changes, or incident response metrics. Dashboards are helpful because raw logs and protocol data can be overwhelming. A well-designed dashboard turns many events into a clearer view of what needs attention. Security analysts might use a dashboard to watch current alerts. Managers might use a dashboard to understand trends and risk posture. Network teams might use dashboards to see device performance and traffic volume. The point is not to make the data look attractive. The point is to make important conditions easier to notice, interpret, and act on. Dashboards can also mislead if the underlying data is incomplete, delayed, or poorly understood. A quiet dashboard does not always mean the environment is safe. It may mean logs are not arriving, sensors are offline, thresholds are too high, or the dashboard is showing the wrong view. A busy dashboard does not always mean the organization is under attack. It may mean a noisy rule, a misconfigured device, or a normal business process that was never accounted for. This is why dashboards need ownership and review. Someone has to know what each chart means, where the data comes from, how current it is, and what action should follow when something changes. A dashboard should support judgment, not replace it. Network management systems, NMS, are platforms used to monitor and manage network infrastructure. They often collect data from devices, track status, display topology, send alerts, and help teams understand the health of the network. An NMS may use SNMP, Syslog, flow data, device polling, and other sources to build its view. For security teams, network management systems can provide valuable context. If an alert appears during a network outage, infrastructure status may help explain what happened. If traffic patterns shift suddenly, network monitoring may show whether a new device, route, or link change is involved. Security and network operations are not the same job, but their visibility overlaps. A security investigation often becomes clearer when network health and traffic movement are understood. Data flow ties all of these pieces together. A router may export NetFlow records to a collector. A firewall may send Syslog messages to a logging platform. A switch may provide SNMP data to a network management system. A scanner may use SCAP content to assess configuration. A mirrored port may send copied traffic to a packet analyzer. A dashboard may pull from several of these sources and present a summary view. The flow usually moves from source to collector to storage to analysis to alerting to reporting. Each step can succeed or fail. If a device stops sending logs, the security team may lose visibility. If storage is not protected, evidence may be changed or lost. If analysis rules are weak, important events may not be noticed. The main takeaway is that monitoring depends on both data sources and the paths that carry data into security tools. NetFlow summarizes network conversations so teams can see traffic patterns. SNMP helps monitor infrastructure health and status. Syslog sends event messages from many technologies into central logging systems. SCAP supports standardized security configuration and vulnerability assessment. Port mirroring copies traffic for deeper inspection when summaries and logs are not enough. Dashboards help people understand important conditions without reading raw data all day. Network management systems connect infrastructure monitoring with operational awareness. These pieces are not separate trivia items. They are ways an organization turns activity into visibility, visibility into understanding, and understanding into better security decisions.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.